Good evening to the participants and our trainer, Dr. Saurav Singla. On behalf of Growing Seed, I would like to welcome you all to the session.
Okay.
So, last session, Dr. Singla taken class on data analysis. So today he will also take classes. So, Dr. Singla, kindly start. All participants joined. Thank you.
Okay. Thank you. Uh, I think last time we had already discussed about the topic of ANOVA. This time we will focus our session on the topic of correlation and regression analysis. So there are so many things, but in these topics, it's a lot. Or we'll try to keep it towards the basics, and as per the need, if someone needs to ask anything advanced, means we are open for the discussion. There is no issues in that. So I hope everyone is ready, and we will start the session. If people are ready, means I will like to see uh, raise hand or something like. Okay, okay. So ready, ready. Very nice. Uh, Need to set up the things a little. Okay. So, firstly, in this part, there are two parts in today's session: correlation and regression. These are two different parts. There's so many times there is a question like whether correlation should be used, regression should be used, what and all, everything. So we will try to answer all such queries today uh, while our discussion. I hope when I'll discuss the topic, most of the queries will get clear. However, if anything still remains, means we will discuss towards the end. Okay. So see, let's first understand the concept of a scatter plot. What is a scatter plot? Then we will dive into the correlation and all. Okay. So what is a scatter plot? Are you familiar with this term, scatter plot? Have you heard it? What it is? What it represents? Or have you seen it? Yes? No? Anything? Friends? No. Okay. Anybody else? No. Okay. So no problem. Let's first discuss what is a scatter plot. Okay. Very good. Reshma knows it. Okay. So in a scatter plot, you see there are a lot of dots in between here. There are a lot of dots, and amongst these dots, we are uh, on there is a x-axis, there is a y-axis, and you see we just first let's focus on this dot. Okay, my mouse is this mouse pointer is visible, no? Pointer, my this arrow device is visible. Yes. Okay. Okay. So this dot, if you see, this is uh, on the x-axis it is 82. Okay, here it is 82. Okay, exactly, because it is lying between 84, 80 and 84. It is 82, and this one, it is little above 75 and quite below than 150. So we guess this value will be near to 85, 90 something. Okay, so this point is showing the value of y, that is value of number of visitors when temperature in Fahrenheit. Okay, this is not in Celsius. Okay, if 82 degree in Celsius means Earth will be boiling, right? So this is temperature in Fahrenheit. So in Fahrenheit, if temperature went to 82 degrees, number of visitors to the beach was roughly near to 90. This is what this dot is telling you. Then when the temperature raised to 84, the number of visitors raised to 225. When it became 86, the number even raised, which is near to 300 and 360. Okay, and when it is, see, this is one point also there where temperature is 87 and number of visitors is little below 150. Then temperature at 88, the number is 450, the number is 525 at 89. Similarly all the dots. Okay, so this is actually, you have the data on X, you have the data on Y. So using the data on X and Y, we can make this plot. Okay. In a similar manner, you can see this one. Here it is a lesser number of data points. It is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Hardly 11 is the number of points. Then there is more number of points. This is how a scatter plot looks like. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think 50 plus points are there in this plot. So what this plot is telling, this is telling on a given simulation time, what was the surface temperature. Okay. If simulation time was 6,700, so these are few readings taken on the surface temperature. If the temperature surface simulation time was 8,000 minutes or seconds, I think this is seconds data. So if it was 8,000 seconds, so these are few readings. So it is not necessary that on every X there is only single reading. There could be multiple readings as well. Just that it depends on the observed data and the experiment. Okay. So this is what scatter plot is. So why we are discussing a scatter plot before discussing regression and correlation and all? Because this scatter plot provide us a rough idea that how these two variables are related to each other. How number of visitors is related to daily temperature, or how the simulation time is independent, how the simulation time is related to surface temperature. Okay, This is, if you see, if you have a look, there is somewhat, if temperature is increasing, the number of visitors is increasing. Okay. So this is giving us a rough idea that these are somewhat, there is a positive relationship in these two, right? Similarly, when you look at this graph, you get an idea that as the simulation time is decreasing, as the simulation time is increasing, the surface temperature is decreasing. Although, although the relationship is not perfect, we will talk about it later, that what is a perfect relationship and what is error and all these things we will talk later. But just to know what a scatter plot is, okay, we want to know, we want to have a rough idea between two variables. Okay. Okay, firstly, one more thing I want to make it clear, that correlation and regression are usually utilized when the variables are of continuous nature. They are not of discrete nature. So, can you tell me the difference between continuous and discrete? Anyone? Or you can say the difference between qualitative or quantitative.
For discrete, we can divide it in discrete classes, but it is not the case for continuous.
Okay, quite somewhat it is right. You said it in very close, very. You are right that discrete could be divided into classes. This is a very nice definition for discrete. But for a layman, for someone who very immature to understand, continuous variable have their values in a range, but discrete values have, very nice. This is also quite correct, that continuous variable has value in range, but discretes have particular values like 2, 3, 4, 5. This is also very right. I think you people have quite an understanding of what is continuous, what is discrete. Although I will try to make it more clear by giving you what is the basic difference between these two. Okay. How these two are different. Whenever you have any variable which is a quantity that can be measured using any scale, like length. Length is a measure that you can measure using centimeter scale, meter scale, feet scale. You can measure using, maybe in terms of light years also you can measure the distance. Okay, so you can measure it. Okay, similarly temperature also you can measure using Kelvin scale, using Fahrenheit scale, using Celsius scale. There are so many scales that you can use to measure different things. Similarly, there is time. Time also you can measure. Okay. However, when it comes to qualitative, Okay. Then it comes to the counting measures. Counting. Earlier, you was measuring it using some scale. But in case of discrete, you are counting it. Like if you have 100 flowers, then you can count how many of them are white, how many of them are of no color, how many of them are pink color, how many of them are brown color or purple color. Okay, that is how you are going to uh, get the, from that you are going to count them. Okay, so that is very basic, that if something is countable, then it is discrete in nature. If something is not countable but it is measurable, like height is there, plant height, height of a human, okay, it is measurable. Weight of a person, okay, this weight is also you can measure. Okay, voltage, current, voltage of the wire, voltage in wire, that also is measurable. So all these things which could be measured are very much the continuous time. Okay, because when you are measuring something, then it depends on the scale that you have, the accuracy of the scale. If you have the accuracy of the scale up to millimeters, then you can write like 19.334567, because up to millimeter, up to nanometer you can have the accuracy. But if you do not have, you have like accuracy only up to the centimeters, then you will write like 15 centimeters, 16 centimeters. That's how. Okay, clear? I think you people have quite an idea, but this is how these two are. Basically, they are different. Okay. Okay. Pearson's. Okay. Now in correlation, what is correlation first? Okay. And wait, is there? I missed that slide. Okay, no problem. Here it is. Okay, here it is. Now in correlation, there are basically two very famous methodologies when you are considering correlation. Okay, what is correlation? Correlation is a quantitative measure which is, assume that you already know that these two variable has some relationship. Like here you see simulation time and surface temperature, these two variables have some relationship, that understanding you have, but how closely they are related, are they uh, how what is the level of a relationship, what is the degree of relationship, you are unable to measure. So correlation is basically a measure that quantifies or which provide the degree of relationship between two variables. Okay, this is basically the degree of a relationship between two variables. That is what is the correlation. Okay, so we should be able to measure what then also measuring also, there is a very beautiful thing about correlation. I will say, you think we will discuss in next slide. So one more thing is that the variables could be related in a linear fashion or also in a non-linear fashion. Okay. Now what is the linear fashion and what is non-linear fashion? linear fashion, in one way you can say that if we plot this scatter plot like this, the points will fall near to a straight line. That is also a form of linear relation. That is what we call linear relationship. But if we want to understand it further, what is linear relationship? Linear relationship means if you are increasing x, like one of the variable, assume in this case simulation time is your x, assume that you are increasing simulation time by 100, then the amount of y getting decreased or increased is also fixed every time you increase or decreased by 100. But in case of non-linear relationship, it is not like that. In non-linear relationship, if you will increase from 6000 to 6100, the simulation time you are increasing from 6000 to 6100, the increase or decrease in y, assume that is 0.5. But when you will increase the simulation time from 8000 to 8100, in case of a linear relationship, we expect that the decrease in y will still be 0.5 only. But in case of a non-linear relationship, it is not constant. It is not constant. It is it is in case of non-linear relationship, it non it would be less than 0.5, it will be more than 0.5, it will be anything. But in case of linear relationship, if the delta x is same, then delta y is also same. That is main relationship. One thing it means that the two variables are linearly related. That means when you make a scatter plot, there will be a linear line, there will be a straight line. However, that also means that the change in x, that is like from 6000 to 6100, that is change of 100 points, will cause a change of y will be constant throughout. But in case of a non-linear, this will not be same. That is the meaning of linear and non-linear. Now, why we are discussing linear and non-linear? The purpose of discussing in non-linear and linear is that correlation as a measure of degree of relationship is only able to measure the linear relationship between two variables. If these variables are related through any other relationship, maybe they have a quadratic relationship, maybe they have a logarithmic relationship, maybe they have an exponential relationship, maybe they have a power function as a relationship. But all these cannot be measured using the coefficient of correlation. Even it is possible that two variables are perfectly correlated using some other relation, but they do not possess any linear relationship, then the coefficient of correlation will give you a 0. That means there is no relationship between these two. So it could be misleading. in case of a non-linear relationship. But in case of a linear relationship, correlation does a quite a good job in measuring the degree of a relationship. Is clear? It is clear, linear and non-linear thing, it is clear or not? Yes? Or should I say once again? Clear. Okay, okay, nice, 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 very nice. Okay. So now there are very commonly used two methods of correlation. One is Pearson correlation and second is Spearman correlation. Pearson correlation and Spearman correlation. Now, what is the difference? Let's first come to the formula of the Pearson correlation. Okay, this is the Pearson correlation. Now, how many of you already know this formula? Or have used it? Anyone? Yes, no? Or it is completely new for you? Don't know. Okay. Anyone else? Okay. So this is a new concept for you, correlation. Okay. So you understand the way. Okay. No problem. No problem. We will. So here we are assuming that there are two variables. One of the variables is x and another variable is y. Like here we were assuming two variables, simulation time and surface temperature. Here we are also considering two variables, x and y, right? We are assuming two variables, one is x, second variable is y. This is just for example. Okay. Now there is a term called covariance. I think variance something is variance that we discussed yesterday. Variance is nothing but summation of xi minus x bar whole square divided by the number of the values. That is a variance. Now what is covariance? Covariance is sum of products divided by the count. Sum of product means x bar represents the mean of x, y bar represents the mean of y, xi minus x bar multiplied by yi into y bar. That means we have coupled values. Matlab coupled values means here you have a value 82, 90. Means x value is 82, y value is 90. Here x value is 84, y value is 225. Here x value is 86 and y value is 300. So we have pair of values xi, yi. We have pair of values. So what you are doing, You are taking the mean of all x values x bar, you are taking all the mean of all the y values y bar, then you are decreasing xi minus x bar from all the values. Xi minus x bar means you are calculating the difference between value and its mean. Yi minus y bar is same for the y variable. Then each difference you are multiplying with the specific difference. That is, if you will calculate the difference from this point, from the mean of all yi, then you will multiply this with the difference of this xi. Okay. So that is called covariance. So covariance will also quite sufficiently tell us that these two are related or not. So if covariance value is quite high, that means there is a relationship between x and y. However, the problem with considering only covariance is that it has no limits. It ranges from minus infinity to plus infinity. That is the problem with covariance. Okay. If we consider only this numerator term, the problem with this numerator term is that there is no limit towards it goes from minus infinity to plus infinity. That is the problem. So we will not be able to decide that relationship is very strong, or it is very less strong, or what kind of relationship it is. So what we are doing, we are dividing the covariance with the standard deviation of x and standard deviation of y. This is the standard deviation of x numerator, and this is the numerator of standard deviation of y. The denominators are not here because the denominator get cancelled. Above and below the denominators get cancelled, so these are not there. So this is the part of the standard deviation of y, this is the part of the standard deviation of the x. So basically what you are doing, you are standardizing the covariance by dividing it with the variance. If you divide the covariance with the standard deviation of x and standard deviation of y, then it gets standardized, and then the value of coefficient r becomes limited from -1 to +1. Okay, from -1 to +1, where -1 means strong negative correlation and +1 means strong positive correlation. We'll discuss what is positive, what is negative, we'll discuss. Just understand that the range of correlation coefficient R is from -1 to +1. That is the result of standardization. That is the result of standardization that we are achieving by dividing the covariance with the standard deviation of x, that is the first variable, and standard deviation of y, that is the standard deviation is the standard deviation of the second variable. So once you standardize, then the value of r is limited from -1 to +1, and then you are able to decide that if value is getting close to +1, then it is a positive correlation, and if the value is getting too close to the -1, then it is a negative correlation. And if the value is staying in between, that is 0, then we can say there is no correlation between two variables x and y. Okay, that is how we Proceed. Now, test of hypothesis. Test of hypothesis means after calculating the value of correlation, we also need to test it statistically. That again, like we discussed no yesterday, that in last lecture we discussed that the value of R is coming, but it might be the result of only error factors. It might be only due to the error factors, not the actual correlation between the X and Y. So we need to test it. We are testing it using the t-test at n minus 2 degrees of freedom. We are testing it. Okay. This is the way how you proceed with simple correlation. This is Pearson's correlation. Okay. This formula is for the Pearson's correlation. Now, the next is Spearman correlation. What is Spearman correlation? What is Spearman correlation? Spearman correlation is also similar measure of correlation only. Okay. But how it is different? How it is different? It is free of the assumptions of a normal correlation. What are the assumptions of normal correlation? The normal correlation has the assumption that both variable x and variable y are coming from the normal distribution. That is the assumption of the Pearson correlation. What is the assumption? That both the variables x and y, both the variables x and y are coming from the normal distribution. Here this x also follows a normal distribution, y also follows a normal distribution. Both the samples are coming out of the normal distribution. But this Spearman correlation is free of such assumption. Now, what is the benefit? The benefit is that sometimes when you are using the real life data, in real life data, this problem might occur. That this problem might occur that your coefficient of your values that you are taking for x variable and y variable are not following the normal distribution. Okay, that is possible in some cases, especially when the sample size is small. In that case, it is very much possible that the population is not normal. Okay. Here, see, do not get confused that I have used two symbols. One is rho and second is R. There is nothing but this is the population coefficient and sample coefficient. Will not get into what is the sample and what is the population coefficient. Will get just to think like these are two same things. Okay, rho and R are the same thing. For today they are same. Okay, the only difference is the rho is for the population and the R is for the sample. That is the only basic difference between these two. Okay. So the formula, what is the difference in formula here? Here instead of multiplying xi minus x bar into yi minus y bar, what we are doing, we are taking the sum of differences in xi and y. Di is nothing but the xi minus yi. What is that is the difference between xi and yi. For all the pairs, we are taking taking the square of it and then sum it, multiply by 6, divide by n into n square minus 1, then subtract the whole from the 1, and it is the Spearman coefficient, correlation coefficient. This also has the same range, minus 1 to plus 1. This also means we have same positive and negative correlations are there. Then this is the same, in same manner you can test this hypothesis as well. There is no difference in this testing also. Okay, the same way you can do the testing as we did the previous one. Okay, now this is what I was talking about, positive negative correlation. Here what is positive negative correlation? What is positive correlation? Positive correlation means the variables are moving in same direction. Same direction means if x is getting increased, y will also get increased. If x will decrease, y will also decrease. Okay, that is the meaning of same direction. See, if I see this, I'll show you this graph. If the average temperature is increasing, the number of visitors is increasing. Average temperature is increasing, number of visitors is increasing. But here, simulation time is increasing, surface temperature is decreasing. Simulation time is increasing, surface temperature is decreasing. Decreasing, increasing, and decreasing. There is a negative relation. Again, if the surface time will decrease, if it go this way, then surface temperature will increase. So simulation time will decrease, surface temperature will increase. So there is a negative relationship. So in case of a positive correlation, the scatter plot will look like this. In case of a negative correlation, the scatter plot will look like this. And in case when the variables are not correlated at all, the scatter plot will look like this. Okay, clear? Are we clear? I think we are all same equal, huh? You are with me. Okay, okay. Very nice, very nice. So let's see here. This is the R code to do this whole calculation. Okay. I forgot to include that testing code. Okay, no problem. I will include. I will show you in later. What I have done in this, I have stored in M, in object M, I have stored the correlation of dataset empty cars. Empty cars is a built-in dataset that is available in R. Okay. This is a built-in dataset that is available in R software. Then using the function core and method Pearson, we got this correlation matrix. Now, what is correlation matrix? What is a correlation matrix? Correlation matrix is a way to represent the correlation coefficients. That is, MPG is one variable, that is miles per gallon. CYL is second variable, cylinders, number of cylinders. DISP is third variable, that is displacement. HP is horsepower. This I forgot to write. This is weight. This is cubic per second. Huh? This is whether this car is automatic. This is empty cars means this is the motor cars data set. This data set consists of data from so many cars. Let me show you if I can show you this data. Cars. Okay, let me stop the screen and share you the another setting. Stop sharing and share Windows. It is showing. Is it showing? So this is empty cars data. You can see there. This is the data of different cars. So many cars are there. Okay. This is all the different data variables. This is a MPG for this car, number of cylinders for this car, displacement for this car, weight, cubic per second, VS, automatic, gears, how number of gears. Okay, all this is showing. Okay, these are all the. Let's check the cars. Okay. And see here. This in full detail it is written what and all it means. Okay. This is weight in LBS. This is real axle ratio. Rear axle ratio. Gross horsepower. Displacement. Number of cylinders. Okay. This is engine is V-shaped or straight. Okay. Automatic or manual. Forward gears or number of carburetors. Okay. This is how this data is. Okay. Please. Just a second. Huh? So this is how this data set looks like. Okay. So we will proceed with the presentation as well. Let's share the slide itself. Okay. Sure. So now what we have done, we have calculated the correlation. Okay. We have calculated the correlation between all these variables as I shown you. We calculated the correlation between MPG and CYL, that is number of cylinders. Then we wrote it here. The coefficient, this is the 0.85 is the coefficient of correlation between MPG and CYL. That is the miles per gallon is showing minus 0.85 correlation with number of cylinders. Is it positive correlation or it is negative correlation? Students, can you please say, participants? It is positive correlation or negative correlation? Am I audible? Negative correlation. Yes, yes. Okay, okay. So straightforwardly, the minus sign is showing us that this is a negative correlation between miles per gallon and number of cylinders. That means as the number of cylinders will increase for our data for this for our cars, the miles per gallon. That means the uh, average miles per gallon is what? Average the number of miles every gallon of petrol the car is running. That is, in India we measure it using kmpl, kilometers per liter. In abroad they measure it using mpg, that is miles per gallon. Mile is the unit of distance and gallon is unit of volume of petrol. So in here it is just like kmpl. Okay, kilometers per liter. So average is very much negatively related with the cylinders. Similarly, this is, can you tell me what this value 0.90 is telling you the correlation between which two variables? Can you tell me? Okay, okay, right, right. So this is correlation between displacement and number of cylinders. So uh, it is 0.9, that is very high correlation, positively correlated. If increase, then the displacement will definitely increase. That is very highly positive linear relationship between these two variables. Now if you see, this value is also same. This is correlation between displacement and cylinder. So this matrix is simply duplication of the information below diagonal and above diagonal. This is the diagonal. This is the diagonal. Okay. This is diagonal. Diagonal elements are 1 because the correlation of MPG with MPG is 1. Correlation of CYL with CYL is 1. So below the diagonal and above the diagonal, the values are just mirrored. If you place a mirror in front in place of the diagonal, then the values will fall exactly on their place in the matrix. Okay. Now, what is the difference between this matrix and this matrix? This matrix is showing you the Pearson correlations, and this matrix is showing you the Spearman correlations. Let's have a quick look at this. Here CYL correlation is 0.85 and here CYL correlation with MPG is 0.91. Okay. Similarly, if you see this correlation VS, okay, this correlation with MP is 0.71, but it is 0.66 in this case. Okay, this is 0.6 is 0.71. Okay, this is 0.91. This also is 0.91. This here it is 0.85 only. It does not mean that Spearman correlation will be always be higher. Okay, here you can see this is the higher, this is less. Okay, here also you can see in automatic, this is lower, this is higher. So don't think like Spearman correlation will be higher or it is lower. There is nothing like that. The only meaning is that Spearman correlation is a better representative when the data is of not of a normal nature. That is the only meaning. Okay, that is the only meaning of using of Spearman correlation, that when your data is not following the normal distribution, then we go for the Spearman correlation. Okay, this basically when it is not following the assumptions of Pearson correlation. Okay, because Spearman correlation does not have any assumptions. It is of a non-parametric nature. We won't go what is parametric, what is non-parametric. Just think like if it is not following the assumptions of the Spearman Pearson correlation, then we will go for the Spearman correlation. Okay. This is that will come up with this pairs command. If you write this pairs command, what this do? This is making the scatter plot of all the variables against all the variables. That's what this command is doing. This is MPG, this is CYL. See if the points were like this in this side, the points were on this, like this in this side. If they are on horizontal in this side, if they are vertical on this side, because in this graph MPG is the x-axis and CYL the y-axis, but in this graph CYL is the x-axis and MPG is the your y-axis. In this MPG is y-axis, CYL is the x-axis. Similarly, all other plots are being drawn. You can see like this is a MPG and horsepower. So these are straightforwardly you can see there is a negative correlation between these two. Here also in MPG and weight you can clearly watch that there is a negative correlation between these two. This you can see displacement and horsepower has somewhat positive correlation. Okay, can see this in this graph also can see they're basically seeing a scatter plot. You can see how good they are correlated or how bad they are correlated. So let's now this is not the only way to plot the correlation. Let's look at some other methods of plotting the correlation. There is a library called core plot. Okay, so this is a library core plot in uh, this R itself. So you can install this, and there are several beautiful present ways to present the correlation. Okay, there are so many ways. This is one way. In this, one addition to the previous is you can see the bluish number. That number that is more blue is close to +1. The number that is close to -1 is quite red in color. See, minus 0.81, minus 0.87, minus 0.85. These numbers are quite red in the color because these are also quite red and they are darker as compared to others because they are higher values of the correlation. The lower value of the correlation represents lesser strength of the correlation. Higher value, higher magnitude, that is more than 0.7, more than 0.8 correlation, whether positive or negative, like minus 0.7, minus 0.8, minus 0.9, these are very high correlations. Similarly, plus 0.7, plus 0.8, zero point 0.9, these are very high positive correlations. So in this, the smaller values are lightened so that the darker values are more visible and we can focus on the important correlations. Okay, that's how These two are, this graph is more helpful than the previous one. Okay, and this is another graph. This is only showing the color. Okay, this is not showing the value, but showing only the color. Okay, this is the another representation. The code is also displayed here. You can see code is also displayed. Okay, here you can have a look that a dual approach is used, in which on the top side the color is there, and on the bottom side the values are there. In this top side you can see the color, and in the bottom side you can see the respective color, and you can see. So this one blue is being represented here, this blue is here, this blue is here, this red is here. Okay, this is mpg with weight, mpg with weight is here. Okay, this is, and in place of diagonal element 1 1 1, it has written the name of the variables. Also this is making the utility, because repeatedly writing 1 1 1 on the diagonal elements does not give you any additional information. Now it is already known that the correlation with gear and gear is 1. A correlation between mpg and mpg will be 1. No need to write. So it is making use of that space by writing the name of that variable in that place. Okay. Similarly, the bubble size, here this size of the circle is also representing, that bigger a circle is, it is representing higher correlation, and smaller a circle is, it is representing lower correlation, lesser correlation. So here, this I have provided a link here. I will see if this open. I will share this tab with you. So you can see this is there are so many ways you can see. There are so many ways to represent correlation. It's very this package provides many diverse manners to display your correlation coefficient. Okay. You can choose as per your requirement, or you can choose as per you like or dislike. This is how the color scales you can use. There are so many color scales available. So this is also a method, like the both number is put inside the number has been written with inside the bubble. That is very beautiful representation. Okay, so inside in this, instead of a circle, it is using a square. Okay, so many ways are there to represent this. Okay, so you can choose as per your need or as per your choice. Okay, this is a way. In this, what it is been in this graph, what has been done, that there is a command core.mtest. This will calculate the significant or not significant correlation as well. So if the correlation is not significant, then it will put a cross over the not significant correlations, so that no need to look upon a non-significant correlation, because not significant correlation means to say is your null hypothesis gets accepted, and null hypothesis gets accepted means to say you have correlation equals to 0. That's what your null hypothesis was. Your null hypothesis was your correlation is equals to 0. In this one also, the not significant correlations has been directly removed from the plot. Instead of placing cross, they have been removed from the plot. This is also another way to represent. So there are so many representations. Here they have put star in the place of significant correlation. This is also one way. And put star also. Okay. So there are so many ways to represent this. I have provided the link in the PPT. You can go through. Okay. So let's now get back to the PPT. So I think this is quite sufficient about the correlation. There is one more thing about the correlation. There are two more types of correlations, that is partial correlation and multiple correlation, that I have not included in this today's presentation. We can discuss that in detail for some other day. That is, partial correlation is used when we want to remove the effect of one variable while studying the two variables. Like if you want to study the effect of uh, if you want to study the effect of heat on increase of uh, visitor in on beach, the count of number of people coming to the beach, and uh, summer temperature. Okay, but you do not want to include the variable of humidity. Okay, humidity might also be one variable that is impacting both, that is correlated with temperature also and related with the visitor count also. Both variables it is related, but you do not want to take it into the count. So you can remove the variation caused by this and consider using the partial correlation. Similarly, there is multiple correlation. Multiple correlation is studying the correlation of one variable with more than one variables. Okay, that is your multiple correlation. Okay, so this is more or less about the correlation. Now I think we should proceed to the regression. So I think correlation is quite pretty much clear. The plots and all everything. Nice. Okay. Others? Good, good. My voice is audible? Okay. Okay. Then we will proceed with the regression. Okay. What is regression? What, uh, how any of you can interpret the regression? Now, firstly, do you know what is regression? That is our first question. What is, how much you know about regression? You just say, you know or no, yes or no. You know or you don't know. Okay. Okay. Don't worry. We will understand what is this. Okay. So, what we are doing, the correlation is allowing you to establish a linear relationship. It is telling you that there is this much degree of linear relationship between two variables x and y. That is what your correlation is telling, that x and y has a degree of relationship 0.9, or x and y has a degree of relationship 0.7 or minus 0.85 whatsoever. Okay. But if there is a relationship between these two, that means I should be able to predict the value of one variable if I have the information on the second variable. Do you agree? If two things are related, that means I should be able to know about the one thing if we have the information on the other, right? You agree? You agree with my point? If I have information on the one, if I have information on the x, and I know that x and y are related, then I should be able to know y based on the information of x. Yes or no? Yes? You agree to my point now? Okay. So you understand this thing, that if we have information on x and we know that x and y are related, then we should be able to predict y if we know x. So that is the purpose which is being solved by the regression. Okay. Now how it is solved? I'm not getting into the derivation part. Okay. Otherwise it will get much more complex. But I'll let you understand how the concept got developed. Okay. See, we discussed the linear relationship. We discussed something that we call linear relationship when we were discussing our uh, when we were discussing correlation. We discussed there is linear relationship. Then we said that points should almost fall on a linear line. Okay, straight line. The straight point should fall nearly on a straight line, like that we told. But it is not necessary that points exactly fall on a straight line. Points might not fall exactly on a straight line. But what we do, we try to figure out the equation of a line from which, if we make that line, then all the points are at the minimum distance. Okay, like this point is this far from the line, this point is this far from the line, this point is this much far, this point is this much far, this point is almost very close to the line, this point is onto the line, this point is a little away from the line, and this point is quite close to the line. Okay. So what is the objective? We so this is the equation of a straight line. If you know the equation of straight line. Anyone, guys? Do you remember the chapter of straight line? Straight line का मतलब क्या होता है? Do you know the equation of straight line? Very nice, very nice, very good. Y is equals to mx plus c. Very good. That is the line equation of the linear straight line. So y is equals to mx plus c is the equation of a straight line. So in case of straight line, m is telling you the slope and c is telling you the intercept. Okay, we'll come what is slope, what is intercept, will come on later. But we are trying to figure out that m and that c in coefficients of regression that are called b and a. We want to figure out that value of m and that value of c which minimize these distances, all the distances from the straight line. Okay, in actual words it is the squared distances. We want to minimize the square of the distances. Why square? Because some if we count on the upside, then this distance is on the lower side, this will counted as negative, so negative will cancel out positive, so but it will not be good for us, we will not be able to judge it. So instead of simple distances, we square the distances. Then we square the distances and then we want to minimize that distance. And while minimizing that distance only, we want to know that value of slope m and that value of intercept c, which minimize that squared distances. Okay. Now this is what I was telling you, that in case of a linear line, the delta x and delta y. Now the slope, if you remember, slope m, the formula for slope m is usually called delta y by delta x. That is the change in x divided by change in y. Oh, sorry, change in y divided by the change in x. That is called the slope m. Okay, and in case of a linear relationship between x and y, the slope will remain constant throughout. However, in case of a non-linear relationship, the slope will not remain constant, it will change from one x to another x. Okay, the delta y by delta x will not be same. The change in y divided by change in x will not remain same throughout in case of a non-linear relationship. Now coming back to this, there are two forms of regression. One is bx plus a, another is y is equals to bx plus a. This is fx is equals to bx plus a, this is y is equals to bx plus a. Now what is the difference? So this is, we are writing that y as a function of x. Fx means function of x. We are writing y as a function of x, and the function of x is a linear function bx plus a. Okay, and here we are writing y itself, that y is equals to bx plus a. Okay, so function of x form, this is the function of x form and this is the y form. Okay, now what is the formula for calculating b? Formula for calculating b is sum of product of x and y. Sum of product of x and y is nothing but this. This is the sum of product. Okay. And divided by the variance of x. This is the variance of x. Okay. So this is the formula for calculating B. So why this formula come up? This formula has came up from the very definition of the regression, that is we are obtaining the coefficient in a manner by minimizing the square of error. Square, this is error basically. The distance between point and line is error. Okay, that is we call error. So we want to minimize this distance, and while minimizing this distance only we get this formula B is equals to sum of product divided by the variance of the x. Okay, this is called the coefficient of regression. And then second coefficient of regression you can put, you can get by substituting. Just substitute. You got y, you got b, you got x, then only a is remaining, then you can get the value of a. Okay, so that is how you get both the coefficients. Now this is called the matrix form of the regression. Matrix form, why it is I am showing you, just to show you a data example. Okay, remind me that I want to tell you about the test of hypothesis in regression, in correlation. We are missing that. We will do in our software. Okay. Uh, in here, we want to show that if there is a variable x, okay, then there will be reading on x, no? Like the reading on first car, reading on second car, reading on third car, and reading on nth car. Then we are making one extra column, that is 1 1 1 1 1, and then there are two coefficients, one is a, one is b. Okay, and there are and then similarly there are paired values of y, that for the car 1 the value of x also, the value of y also. For the nth observation, value of x also, value of y also. So this is basically representing the matrix y, this is representing the matrix x, and this is representing the matrix b. Okay, so we are doing what we are doing to get the value of matrix b is we use this formula, that is transform of x into x whole, we take inverse, and then we multiply this inverted matrix with transform of x, and then we multiply it with the y. Okay, that's how you determine your, that's how you determine your uh, b, that is the coefficient of regression. Now some people might think, sir, why we cannot directly take the inverse of x? So x is not invertible. Okay, x you cannot take directly, you cannot take inverse, because x should be a square matrix, then we can take the inverse of x, otherwise you cannot take the inverse of x. Okay, and we want a formula that is applicable in all the situations. So that is how, why we cannot directly take the inverse of x and calculate the values of b. Okay, so let's proceed to the analytics part. Okay, okay, assumptions. First, let's discuss the assumptions of linear regression. What are the assumptions? First assumption is linearity. Obviously, I told you that regression also. Okay, one more thing you people should understand. Okay, many people gets confused. What is while interpreting the regression? In regression, you are estimating the value of one variable from the another, from the value of second variable. Okay, I am assuming that you are estimating the value of y using the value of x, but it is not that x y is dependent on x. the regression analysis cannot be used to determine the causality. X is not causing Y, or even if it is causing, then it is not the regression analysis using which we can establish the relationship that X is causing Y. The causal analysis is a different thing. There might be physics involved, there might be chemistry involved, there might be economics involved, there might be n number of theories that can be involved, but not the regression analysis, which will be deciding that there is the dependency between X and Y. That is, X is causing Y. It cannot be concluded based on the regression analysis. Or Y is causing X. That also cannot be determined by the regression analysis. That must come from some other theoretical analysis, not from the empirical analysis. So statistics is basically an empirical analysis. So you cannot establish a cause and uh, cause relationship, cause and occurrence relationship based on the statistics or based on the empirical analysis. For that, you must have to go into the theoretical analysis to establish a causal relationship, that is X is causing Y or Y is causing X. For that, you need to go to the theory. You cannot rely directly on the uh, this analysis. Okay. Now let's move forward to the assumptions. There are linearity is clear that we cannot go for the non-linear relationships. This is compulsory. Second is multicollinearity. Multicollinearity means what? If you are taking more than one explanatory variables, that is on this x side, you are taking x1, x2, x3, like that you are taking some other variables as well. Then multicollinearity assumption says that these variables must not be correlated with each other. There should not be any correlation between these two variables, or there should not be any significant correlation between these variables if you are taking more than one x variables in case of regression analysis. Remember, you can take more than one x variables, but you cannot take more than one y variables. Okay, you cannot take more than one dependent variables, but you can take more than one independent variables. If you take more than one dependent variables, then it will be called a multivariate regression analysis, which is not this. This is simple regression. Okay, or multiple regression. This is not multivariate regression. Okay, this is multiple regression or simple regression if only one x variable is there. That is called multicollinearity. That is, there is no correlation between the explanatory variables. That is, no correlation between the x variables. Okay. Then autocorrelation. Autocorrelation is telling that, okay, there is some one more term in this model, that is error term. In here, it should be bx plus a plus e. Y is equals to bx plus a plus e. E is error. Okay. So autocorrelation is telling that your x term is not correlated with error. Okay. Autocorrelation assumption is telling that the error terms are not correlated with the x. Then normality. Okay. What is normality? Normality, again, as I told you before, first thing is that both the variables are coming from the normal population. Also, it is saying that the residuals, we are not getting into what are the residuals and all, but it also means that residuals or the errors of this regression analysis follow the normal distribution. What is the homoscedasticity? Homoscedasticity is telling us same thing like we said no yesterday, homogeneity of the variances. It is same thing. Homoscedasticity is telling you that the variances should be homogeneous throughout the analysis. Okay, that is called the homoscedasticity. Okay, So now let's proceed with the example. So here I have taken an example. Okay, I taken horse pump. Actually, I should take the MPG. Just give me a second. Huh? Okay. MPG and weight. Okay, we are considering two variables here. This is the command. The command is that MPG, okay, MPG is miles per gallon. Okay, miles per gallon is we are predicting the average MPG when taking the weight of the car. Okay, we are using this empty cars data set in which we are using two columns, MPG and weight. Okay, and using the linear regression, we are trying to predict MPG and weight. Now, what we are getting here, after doing the analysis, we are getting this estimate. This is the estimate, this and this. So estimate is telling you that your A is 37 and your B is minus 5.3734. So here in this equation, your A is 37.28 and your B is minus 5.34. So what it is telling? Firstly, it is telling that there is negative relationship. Higher is the weight, lower will be the MPG. Also, it is telling you that if weight increases by 1 pound, okay, if your weight of the car is increasing by 1 pound, your MPG, okay, miles per gallon is going to decrease by 5. Okay, so that means there will be very high impact of uh, weight on your average. Okay, also that also means that if you decrease the weight by 1 pound, okay, I think actually it is 1,000 pounds. No, we see that it is 1,000 pounds. Okay, so it is the weight is taken in 1,000 lbs. Okay, the unit of weights is 1,000 lbs. So if the uh, weight of the car is decreased by 1,000 lbs, 1,000 pounds is been decreased, then 5 miles per gallon average will increase. Okay, that is the meaning of the coefficient minus 5.34. And what is the meaning of coefficient A? That is 37.28. 37.28 means actually it is a bit it is bit abrupt to say, but it means that even if there is a no weight of the car, okay, if the car is not having any weight, even then the car will give somewhat the average of the highest possible average of the car is 37. Okay, in case you minimize the weight, that is your intercept. 37.28. Okay. Now, what is been shown here? I think one more slide was there. Uh, no, testing was there. Yeah, this itself it is there. Okay, might be. Okay, here itself we have it. Hypothesis test. Okay, this should have come in new slide. This is not coming. Okay. So hypothesis test is done using F test for the model, and for the coefficients we do the T test. So how you can see here, you see here F has been calculated for the model. F value is 991.38 on 1 and 30 degrees of freedom. So definitely P value is e raised to power minus 10. E raised to power minus 10, that means very small P value is showing. That means your model is significant. There's no problem with the model. Okay. Then again, you can see that your R square value, this is multiple R square value, is 0.75, or the adjusted, you can see that always try to look at adjusted R square. Okay, that is better value. Adjusted R square is 0.74. That means it is telling you that 74% of variation in miles per gallon could be explained by the weight variable. So 0.74 means the linearly explainable variation in miles per gallon using the weight variable is 74%. Is this clear? You got my point? That is the linearly explainable variation in miles per gallon variable. Okay. Is it okay, guys? Linearly explainable thing, it is okay? Yes? Then here we are testing the coefficients. Okay. Coefficients we are testing using t-test. Okay, t-test is here, and then here is the p-value to check the t-test. Okay, p-value of t-test is coming the 0.10 raised to power minus e raised to power minus 16. That is also again very low, and the here also it is coming e raised to power minus 10. That is very low. So we can see that this is very clearly both the coefficients are significant. This the there is a pattern in regular pattern is visible, that there's a problem with this plot is called, if these dots are very same on the line, there's a problem model pointer line, so it is okay. Residual against fitted values, almost same plot that has been here, just this is residuals and this is the standardized residuals. Okay, and this is the leverage. So these there are few points which are showing high leverage, that is these points are causing little bit deviation in the parameter. That is not the topic of today's discussion. We will discuss in some other, it's a very technical thing that we can discuss on some other day. Okay. One more thing I want to show you is the testing of the correlation. Okay, so let me show you that part also once, if possible. Just quickly I will cover it. Uh, it is in it is not allowing to share. Okay, let me share the entire screen. Okay, so assume that your x variable is nothing but, let's clean this. Let's put it here. That is empty in empty cars dataset. In X empty cars dataset, there is a MPG variable is X and Y is equals to uh, weight in empty cars. Okay. So if you want to find the correlation between X and Y, simply you give like this. This is the correlation between X and Y. Then if you want to test this correlation, then there is the this command core.test. Then this is how you get this. This is the results of the test. You can see the p value is quite low, that is 1.29 into 10 raised to power minus 10. That means very small. This value is in 0.00000 something, then 1. So that is very small value. So that means this is significant. Okay. So that's how you can test the significance in the R software. Okay. So with this, I would like to end this session, and it is open for the queries now. Anything you want to ask related to this regression, correlation, anything else you want to, huh? It is open. Okay.
Thank
Thank
you.
you. Yes, yes, yes.
Thank you, Dr. Singla, for presenting such a nice session. So we have learned a lot of things, and thank you for explaining such a. I mean, it's a big thing. So in a short time, you presented very well. So I want to ask our participants, if you want to ask anything, you can write it on chat box, or you may also write it to the WhatsApp group, so that sir can answer that thing on next classes, or you may contact him directly also.
Okay, there are
Okay.
there is one query that to demonstrate some software application practically, it will be beneficial for us. I will provide the code there. You can use it for your data, or if you face anything miss, you can tell me. And is telling how to arrange data. Arrange, see, there is two formats of the data. There is one is called long format of the data, one is called the wide format of the data. Okay. So always when you want to use R software or such kind of software, that then definitely you need to arrange your data into the long format of the data. Okay. When you have when you want to use some other software, maybe that software might have specific requirements. But if you are using standard SAS, you are using R software. That time you must use a long format of the data. Okay, long format means all of your data will come in one row. Okay, let me try to show if I can show you. Uh, okay. So if this is your treatment will go in one column, replication will go in one column, and observation will go in one column. Okay. Say treatment first, replication first has some value of 30. Then similarly, you cannot change the font. Okay. If you are using capital T1, then use capital T1 only. Here also capital R2 means capital R2. Second replication value is say 15. Then third replication value is say 17. Okay. So this is then the value of T2. You have to put T2 R1. Okay, that's it. So this is third treatment, the values of all the replications. So once you have entered for one observation, you can similarly enter here for second observation, third observation. No need to write these columns again and again. Okay. This is only for once you need to write. Oh, this should have been like this. Okay. Similarly, you will continue up to the all the treatments and all the replications are finished. You will write, and all the values you will write for the first observation, like maybe the number of tillers, something, whatever the variable you want to have. Then second variable, third variable. Then similarly, you will arrange for all the variables here. Then you can give it as an input to the software. Okay. So anything else? Software applications I told already. Okay. Any other query? Okay, if we have time, some other time, if we get some time, then we will take one small session in which we will only show how to run the code or using some give. I will provide some data, but let's see the availability of these slots or anything. But because that won't take much time, actually, that is not complete session is not possible on that. But let's see. Kindly mention the sites where we can get where is a very uh, common website. There is our companion. Okay, I will share our companion. Okay, there is a book. Okay, you can always use this. Is a very authentic book. You can use these codes. Okay. Where we can learn now, it is a bit difficult. Just it is everything you can learn by practice only. Okay, you can start from small and then slowly you can proceed, because in one day you won't learn everything, no? And slowly you start doing small things, then you will slowly get to understand how to do, because it is just like any other language. Just you learn uh, whatever other language you want to learn. Like you in childhood, you want to learn English. English also we learn in 1 year, 2 year, 3 year. Then slowly we learn. Like that only this is also language. You learn in 1 year, maybe in 6 months also you can learn. Okay. So based on that, right? Then anybody else? Most time my script is wrong, so how can I correct it? Oh, yes, this happens. When you are a newbie, it is very much possible that your script goes wrong. Then when your script is wrong, always what you do, you just copy the error message that is showing on R and paste it in Google blindly. Something will be, you will get the solution. My some basic demo. In my slides already I have some code. I will share these slides. Okay, I will share these slides. No problem. Is there any AI tool which can correct it? Usually AI tools are helpful. I'm not saying they're not, but you cannot blindly rely on them. No, you have to do the interventions. It is not possible that directly whatever that software is giving, that is we can use. Okay, we have to do a little bit of changes in the code as per the requirement, as per our data, as per our uh, this. So that's in that way you can. It is not that even many a times chat GPT is useful, but it won't give you exactly the same thing you want. It will give you somewhere nearby what you want. Then you have to modify it. Then anyone? So I think yes, yes. Oh no.
Okay, okay. Thank you, Dr. Singla. I think you have cleared the conclusions. And if someone wants to ask anything, so you can write it to the WhatsApp group.
Ah,
And
sure.
okay, okay. Thank you. And okay, then we are now closing the session. Thank you to the participants, and thank you, Dr. Singla, for taking such a nice session.
Thank you,
And
doctor. Thank you.
thank you.